All right, now we're going to sketch some radical functions. Okay, so the first thing that's helpful to know is, is the idea of a parent graph. So if this started off just being the square root of x, well, if you did an xy table, well, the smallest, without imaginary numbers, the smallest value for x could be 0, and the square root of 0 is 0. 1 is a perfect square. The square root of 1 is 1. The next perfect square is 4. The square root of 4 is 2. The next perfect square is 9. The square root of 9 is 3. So I'm going to plot that in red. So at 0, 0, at 1, 1, 4, we're at a height of 2, and I'll put 9 right about there. We're at a height of 3. So this is what's called a parent graph. This right here is the parent function. Before anything happened to it, this is what it would have started from. This is what the parent graph of the square root function looks like. All right, now it's asking for the domain and range. So on a square root function, look at the x's start at 0 and it's headed towards positive infinity. So for the parent graph, that's the domain. Well, let's look at the range. It's also starting at 0. So for the range, the lowest point is 0. And while it's going to the right, it's also going upward. So that's also positive infinity. So here's a tip. Now we're going to do this problem right here. And let's do a table of values. And for the parent function, the starting point is 0, 0. So you're looking for the lowest value of the x, what the x can be. So what we're going to do to find that starting value, you take the opposite of this and this exactly. Here, let me write that in green. So the opposite of negative 3 is 3, and then 1. So at 3, 1, and guess what? That's the starting point of the domain and range. So one thing that's really easy, look at the x value, and the opposite of negative 3 is 3, and it's going to be a solid dot touching, so we put the square bracket, and then since it's headed to the right, I think I just said that strangely, and then for the range, instead of starting here at 0, the lowest point is going to be that positive 1. And while it's going to the right, it's still going up. So that's how you find the domain and range. You can look at the first two, the x and y value, the first values in the table, and that tells you what the domain and range will be. Then, so since on this one, we went over 1, so I'll go over 1. So it'll be 4. And when I put 4 in here, 4 subtract 3 is 1. The square root of 1 is 1. 1 plus 1 is 2. So we're at a height of 2. So, okay. Now, in this original table, I went 1 and then I went 3. So I'm going to go over 3. So I'm going to be over here at 7 now. And notice each time I'm just going up 1. But let's try. So if we put a 7 in here, 7 subtract 3 is 4. The square root of 4 is 2. 2 plus 1 is 3. So at 7, we're up here at 3. And then from 4, I went over 5 places. So I'm going to go over 5 places. Well, 12 will be, I don't know, over here someplace. And we just keep going up by 1. But we can also try, we'll put a 12 in here. 12 subtract 3 is 9. The square root of 9 is 3. 3 plus 1 is 4. So at 12, we're up here at 4. And so this is our transformed, the graph that they give us, our transformed graph. So I'm not going to do this whole one, but we take the opposite of this. Remember, this is the x value in the domain, and we take this exact. So if you do the table, you're starting at -5, +1, right? And then remember what we did here? We went over 1, then went over 3 more. We went over 1, then went over 3, then we went over 5. So we're going to go, we start here. We're going to go over 1. We're going to go over 3. And then we're going to go over 5. And each one of these is going to look like that. So, and then this dictates domain, the opposite of. This dictates range. All right. All right, that's it for this one.